let's discuss series of functions. Hello everyone. First, let's define a series of functions. Let f sub n go from e to the set of all complex numbers for n greater than or equal to 0, where e is a subset of the complex numbers. We say that the series of functions, the sum from n greater than or equal to 0 of f sub n converges uniformly if the sequence g sub n from n greater than or equal to 0 converges uniformly for g sub n of z equal to the sum from k greater than or equal to 0 to n of f sub k of z. In other words, if and only if for every epsilon in the positive real numbers there is some capital N such that for all n greater than m greater than n and all z in E, the modulus of f sub n of z all the way up to f sub n of z is less than epsilon. Now let's define the majorant. Given a series, the sum of all n of f sub n of x of functions and a series, the sum over all n of a sub n of positive real numbers, we say that the sum of all n of an is a majorant for the sum of all n of f sub n of x if there is a constant m such that for some capital N we have that for all n greater than or equal to n and all x we have that the modulus of f sub n of x is less than capital M of a sub n. We say that capital M is a coefficient of majorization. Now let's move on to the Weierstrass M test. Suppose that a sub n is a sequence of positive real numbers such that the sum over all n of a sub n is a majorant for the sum over all n of f sub n of x, and such that the sum of all n of a sub n converges. Then the sum over all n of f sub n of x converges uniformly. Now let's mention the comparison test. Suppose that a sub n and b sub n are positive real numbers for all n. If a sub n is less than or equal to b sub n for all large enough n, then the convergence of b sub n over all n implies the convergence of the sum of all a n for all n. Now let's mention the ratio test. Suppose that a sub n and b sub n are positive real numbers for all n. Suppose that the limit as n approaches infinity of a sub n plus 1 divided by a sub n is equal to r. If r is less than 1, then the sum over all n of a sub n converges. If r is greater than 1, then the sum over all n of a sub n diverges. If r equals 1, then the test doesn't give us any information. The series may or may not converge. Now let's discuss the ratio comparison test. Suppose that a sub n and b sub n are positive real numbers for all n. If, for all large enough n, a sub n plus 1 divided by a sub n is less than or equal to b sub n plus 1 divided by b sub n, then the convergence of b sub n implies the convergence of a sub n.
As ever, thank you for watching.